So then let's look at how you would do an ANOVA, whether it's post hoc testing, to see if there is a statistical difference between different scores when we have more than two groups. Remember, you do a t-test if there's two groups. If there's more than two groups, you do ANOVA, and then you see if there is a difference between any of the groups using post hoc testing. This is the SPSS file we had from our previous example where we looked at the t-test, where we just had two groups, group 1 and group 2, and these were our scores. So what we're going to do now is just add to that with some extra scores. So our example is going to be, if I close our previous example, if I open up one where we've got 4 groups, so A, B, C, D, and we've got some different scores. Again, these are scores achieved in a test, and group 1 and group 2, we saw that there is a statistical difference between those two, but now we want to put in group C and group D. So because there's more than two groups, it's now going to be an ANOVA, and so what I'm going to do is copy group C. So copy, Control C, go into the SPSS file, paste into there, scroll down. This is group 3, so 3, 3, 3, 3, 3. And then we do the same for group 4. So go back to Excel, and then copy that, all those data, Control C, go into SPSS, there it is, paste, that's group 4, so let's type in all the 4s. That's it. Now we want to do, well, let's just save it. File, save as. Results, let's have that as results 4 groups. It says we've saved that in the output window. Let's reduce that down. So first thing, we want to check if the data is normally distributed. So remember what we do, we go to Data, Split File, and then we want to split it based on groups. So we put groups into here, and that window is deactivated because we have to press Compare Groups. Drag groups into here, then press OK. And then I think, yeah, it says it's split file. Reduce that down, and then we want to do the statistics, do the normality tests, which is under Analyze, Descriptive Statistics, Explore, and then let's just reset that. So you want to put score in the dependent list, group in the factor list, make sure both is ticked here, statistics, confidence interval 95% still, so alpha is 0.05, plots, make sure we've ticked normality plots with tests, and let's have a histogram and a stem and leaf. In fact, let's not have the stem and leaf this time, let's just have the histogram, and then press continue. Options, there was nothing there, and bootstrap we don't click, so OK, and our output then comes up. So let's see what we've got here. We've got our scores for group 1, 2, 3, 4. We can see that there are different n numbers, depending on how many items there are in each group. And then we got the means for the various groups. So we got 59.85, 71.55 for group 2, and then group 3, 71.50, 76.76. So there are differences, but we don't know if there's a statistical difference. But we look at the Shapiro-Wilk test. So this is the important one, test for normality. And we see that each of the groups here, 1, 2, 3, 4, all got values greater than 0.05, therefore all the data is normally distributed. And we can see that in the histograms as we go through here. Okay, so 1, 2, 3, 4. And there's also those QQ plots which should be linear, which they are. And oh, it has got the stem and leaf. I thought we ticked that it wouldn't, but okay, never mind. Right, okay, so data is normally distributed. Now we want to go back to the data and do the F test, otherwise known as the Levine's test, and also the ANOVA, and then also the post hoc testing as well. So let's go to, first of all we need to go back to data, and then where it says split file we need to unsplit the file. So we can go, if we go to analyze all cases, that grays out that box there. So we're going to analyze all the data. Press OK. I think down the bottom of this output window it does actually say unsplit or something. Yeah, split file off. Okay, so that's good. And then we do analyze, compare means, one-way ANOVA. And we're going to put score in the dependent list. Group is going to be the factor. Contrasts, ignore that. Post hoc. Okay, so there's different types of post hoc testing, so I would read up about which one is appropriate for you to use. Standard one is the 2-key test, so I'm going to tick that for this example. The significance level I'm going to keep down there as 0.05. Let's press continue. Options. Now with the options we're going to tick the homogeneity of variance test, so we click that one. That will be our F test. Bootstrap, ignore, so OK, and then out will come our results. So let's have a look what it's done. So if I go at the end of the box plot, test for homogeneity of variance, and we have, based on the mean, 0.712, which is greater than our alpha value, 0.05, therefore we have homogeneity of variance. So we can now proceed to the ANOVA. If it wasn't, if you didn't have homogeneity of variance, you'd have to go and do a Kruskal-Wallis test, which is a non-parametric version of the ANOVA. But because that value is greater than 0.05, you can proceed. Oops, there was our ANOVA results. Here. Okay, so we look at this value here, 0.000, and if I double click on it, it will tell me what the actual value is. Double click. Or is it single click? Yeah. 0.00219. So that's less than 0.05, our alpha value. Therefore there is a significant difference between at least two of the groups. But we don't know which groups they are. There might be 1 and 4, 1 and 2, 2 and 3, etc. So what we do then is look down the post hoc testing, and that table there gives us our results for that comparison. So group 1 and 2, significance 0.011. So that's less than 0.05, so there is a statistical difference between 1 and 2. Between 1 and 3, 0.010, so that's less than 0.05, so there's a statistical difference between 1 and 3. 1 and 4, also a difference. Again, if we single click, or is it double click? Yeah, I think it's double click first and then a single click second, so a bit odd. But then we see what the actual value is there, 0.000166. So there is a significant difference between 1 and 4. Between 2 and 1, well, that's the same as 1 and 2, so there's a bit of replication there. 2 and 3, that's a new one. No, that value is greater than 0.05, so there's no statistical difference between groups 2 and 3. And also between 2 and 4, no difference, because we've got a value there, 0.53, which is greater than 0.05. It's greater than that, so there's no significant difference there. 3 and 1, that's the same as 1 and 3. And 3 and 2, same as 2 and 3. So half of this table is duplicated, but there are some differences that we haven't done 3 and 4 yet, and we see there's no difference there because that value is greater than 0.05. So between groups 3 and 4, no difference. 4 and 1, same as 1 and 4. 4 and 2, same as 2 and 4. And 4 and 3, same as 3 and 4. Okay, so between some groups there's differences, and other groups there's not differences. And in order to see which ones are greater than which, you look at the means table, which is right up at the front. So use these differences in the means to know which one's greater than which group, but then look at the post hoc test table to see where those differences actually lie.